Lesson 5 of Unit 5 in the polynomial function equation unit. We're now about to go over solving polynomial equations, and we're going to factor this time. We're not going to graph. All right, so just looking at our steps, we got to make sure we move all terms to one side, okay? So we're going to get our terms for whatever polynomial equation that we have, and we're going to set it equal to 0, okay? Very, very, very important. Okay, just like we did with quadratics, we make things equal to 0. Then we have to make sure that we factor it completely, okay? Make sure you're factoring the entire polynomial completely. Greatest common factor, quadratic equation, if necessary, regular factoring, grouping, slide and divide, whatever is necessary. Okay, after that, then we got to remember that we set each factor value equal to 0 and we solve. Okay, please, please, please make sure that you solve for each x value so we know that the number of roots that we have for our polynomial equation. Okay, for quadratic equations, make sure you solve by square roots completing the square or the quadratic formula. You'll be able to do some factoring with those quadratic equations like we learned before. And then we have to make sure that we simplify all irrational and complex solutions. So if it's a square root, we make sure we get it in the simplest square root form. And if it's a complex solution that includes I, and it is a fraction, we make sure that fraction is simplified as well. Jumping straight in, we have number 1, x cubed plus x is equal to 0. I must factor it first. Well, I can factor this using a greatest common factor. The greatest common factor is x. So I have x times x squared plus 1, and that is equal to 0. Okay, once again, we must set our factors equal to 0. So I have x equals 0, and x squared plus 1 is equal to 0. We solve this right factor of x squared plus 1 by using square roots. So I get my isolated term of x squared, and then I have minus 1 on the other side. Make sure that you take the square root of both sides. The result of this would then be x is equal to plus or minus I. Remember, the square root of -1 is plus or minus I. Furthermore, my solution would be x is equal to the solution set of plus or minus I and 0. For number 2, we have 4x cubed minus 7x squared equals 3x squared. We want to set this polynomial equation equal to 0. Therefore, we have 4x cubed minus 7x squared minus 3x squared, and that is equal to 0. Simplify. 4x cubed minus 10x squared is equal to 0. Now I need to take out my greatest common factor. Since I have 2 x's on the left side, that can come out. I have an x squared, and then a 2 can also come out from 4 and 10. That leaves me with 2x minus 5 equals 0. Setting both of my factors equal to 0, 2x squared equals 0, therefore x is equal to 0, and 2x minus 5 equals 0, therefore x is equal to 5 over 2. When you add 5, then divide by 2. So my solution set would read x is equal to the set of 0 and 5 halves. For number 3, I have x to the 4th power minus 64 equals 0. I notice that I do not have a greatest common factor. So next I need to check for perfect squares. I know that 64 is a perfect square. The square root of 64 is 8. But x to the 4th is also a perfect square. The square root of x to the 4th is x squared. Therefore, I have an a squared minus b squared problem. And remember that this breaks down to a plus b, a minus b. Therefore, my a value would be equal to the square root of x to the 4th power, which is x squared. So x squared is the first piece of my factoring. Then I have b, which is the square root of 64, and the square root of 64 is 8. Therefore, b is 8. So I have x squared plus 8 and x squared minus 8. And I have that equal to 0. Remember to set both of my factors equal to 0. So I have x squared plus 8 equals 0 and x squared minus 8 equals 0. Solving them both, I have x squared equals negative 8. And then I have to take the square root of both sides. So that leaves me with x is equal to the square root of negative 8. Well, the square root of negative 8 is equal to plus or minus I times the square root of 8. The square root of 8 breaks down to become the square root of 4 times the square root of 2. Therefore, for this factor, the final solution for this factor is plus or minus 2i times the square root of 2. For the second factor, I add 8 to both sides, so I get x squared is equal to 8. Take the square root of both sides, I get x is equal to plus or minus 2 times the square root of 2. Therefore, my solution set would be equal to plus or minus 2i times the square root of 2 and plus or minus 2 times the square root of 2. And since our degree is 4, I am able to have these 4 solutions within my solution set. Number 4 reads 5x to the 5th minus 80x is equal to 0. I do have a common factor that I can bring out in 5x, and that would leave me x to the 4th minus 16, and I set that equal to 0. Can I still factor on the left side? Yes, I can factor the x to the 4th minus 16 using square roots. That is an a squared minus b squared problem. Therefore, I have 5x is equal to x squared plus 4 times x squared minus 4, and that is equal to 0. Now, I also see that I have another a squared minus b squared in the term of x squared minus 4. So I have to continue to factor where factoring is available. So I have 5x times x squared plus 4, and then x squared minus 4 breaks down to x plus 2 times x minus 2, and that is equal to 0. Now I must set each factor that I have equal to 0. Therefore, I got 5x is equal to 0, x squared plus 4 is equal to 0, x plus 2 is equal to 0, x minus 2 is equal to 0. So I know for x plus 2 and x minus 2, it equals the opposite sign. Those are easy solutions for us to have. For the x squared plus 4, I get x squared equals negative 4. Then I take the square root of both sides. X is equal to plus or minus 2i. And then for 5x is equal to 0, x is just equal to 0. Therefore, my solution set would be equal to 0 plus or minus 2i and plus or minus 2. Since my degree is 5, you can see that I have 5 total roots, which is the maximum number of roots that I can have as a solution for this polynomial. Number 5 reads x cubed plus 125 equals 0. First things first, look for a greatest common factor. I do not have one. Since this degree is cubed, I know that I have some formulas as the sum of cubes and the difference of cubes, and I want to look at those first. Since this is a plus sign, I'm looking for the a cubed plus b cubed, and I have to think of my perfect cubes. Is x cubed a perfect cube? Yes, it is. That would be x. Is 125 a perfect cube? It is a perfect cube. it would be 5. Therefore, A is equal to X and B is equal to 5. Now, the formula reads A squared minus AB plus B squared times A plus B. So that is the sum of cubes formula that I would plug my A and B values into. Therefore, I have X plus 5. That's my A plus B. X squared minus 5X plus 25. That's my A squared minus AB plus B squared. Now I'm going to set both of these equal to 0. So X plus 5 is equal to 0. And then X squared minus 5X plus 25 is also equal to 0. I can tell you right now that for my second factor, we're going to have to use the quadratic formula, or you can use completing the square, whichever one that you choose to use. For the left, I have X equals -5. Knowing that I'm using the quadratic formula, X is equal to -b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Simplifying this, I have 5 plus or minus the square root of 25 minus 100 over 2. That is equal to 5 plus or minus the square root of -75 over 2, which is equal to 5 plus or minus 5i times the square root of 3 over 2. This cannot be simplified, therefore I leave this because it's already in simplest form. And for my solution set, X is equal to -5, 5 plus or minus 5i root 3 over 2. And as you see, that is 3 solutions or 3 roots. I have -5 and then 5 plus or minus. Those are 2 different solutions. For number 6, we have 8x to the 5th power plus 5x squared equals 4x squared. We must set the polynomial equal to 0, which gives us 8x to the 5th plus x squared, and that is equal to 0. Taking out an x squared as my greatest common factor, I have x cubed. 8x cubed plus 1 is equal to 0, and that is what's left. 8x cubed plus 1 also follows the sum of cubes. 2x would be the cube root of 8x cubed. Therefore, x squared would be times 2x plus 1, which is times 4x squared, minus AB, which is 2x and 1, so this would just be 2x in the middle, plus 1 squared, and that is all equal to 0. Setting my first factor equal to 0, I get x squared equals 0, so x is equal to 0. For my second factor, I have 2x plus 1 equals 0, therefore x is equal to -1/2. And for my last one, I have to put it into the quadratic formula. Therefore, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2 times a. So now, moving forward and simplifying, I have 2 plus or minus the square root of -12. That -12 comes from 4 minus 16. Okay, 4 minus 16. -2 squared is +4. -4 times 4 is -16. So 4 minus 16 gives me -12. And that is all over 8. Continuing my simplification, that is equal to 2 plus or minus 2 I times the square root of 3, and that is over 8. Remember, when we have a negative, we can bring out an I, and 12 breaks down to the square root of 4 times the square root of 3. The square root of 4 is 2. That's where I got my 2i from. And then I need to simplify this, so I get 1 plus or minus I root 3 over 4. So if I put all of this into my solution set, I get x equals the set of negative 1/2, 0, and 1 plus or minus I root 3 over 4. For number 9, we're looking at x to the 4th plus x squared minus 42 equals 0. Do not have a greatest common factor, so I'm looking at perfect square roots. It's not a perfect square root. So the next thing that I remember is that when I go from my first term to my second term, if that degree cuts in half, I can look into factoring it as we would factor a normal quadratic equation. Therefore, I am looking for the factors of negative 42 and add to be positive 1. Without going through all the factors of negative 42, I can tell you that 7 and negative 6 will add to give me positive 1. So those are my factors. I take my middle term, which is x squared plus 7, just like I would in a regular factoring situation. And this is x squared minus 6. And that is equal to 0. Remember that I can only do this because x to the 4th is my first term, and my second term is x squared, which 4 divided by 2 gives me 2. Therefore, I can break it down this way. Setting both of my factors equal to 0, I get x squared equals negative 7, and x squared is equal to 6. Taking the square root of both sides for both factors, I get x is equal to plus or minus I times the square root of 7, and x is equal to plus or minus the square root of 6. These square roots cannot be broken down any further. Therefore, my solution set would be plus or minus I times the square root of 7 and plus or minus the square root of 6. For number 13, we're going to go ahead and set that equal to 0. Therefore, we get 3x to the 4th minus 2x squared minus 16 equals 0. Cannot do a greatest common factor. There is no perfect square root. 16 is, but 3x to the 4th is not. Therefore, we must look into solving this regularly. By factoring, we can use the slide and divide method. And remember, if you use the slide and divide method, then we multiply the 3 times 16 only, and that gives us x to the 4th minus 2x squared minus 48. Now, we factor this polynomial that we have in front of us. Therefore, factoring this, we have x squared minus 8. And then we also have x squared plus 6. Those are equal to 0. For slide and divide, we have to go back and divide our factor, the number in our factor, by the number we multiplied with in the beginning, which is 3. Some of you missed this on the last quiz. Some of you missed this on the last test. So make sure when you slide and divide, you got to go back and divide that by 3. Now moving forward, I have x squared minus 8 thirds, okay? And then I also have x squared plus 2 equals 0. And I can leave these as is, but I have to set each one equal to 0. So x squared minus 8 thirds equals 0. X squared plus 2 equals 0. On the left factor, adding 8 over 3 to both sides gives me x squared equals 8 over 3. Take the square root of both sides, and that gives me x is equal to plus or minus 2 times square root of 6 over 3. To get that answer, do not forget that you must rationalize the denominator. Rationalizing the denominator is very similar to what we did with the I values. You multiply the top and the bottom by the square root of 3. The top gives you the square root of 24. The bottom gives you 3. If I do the square root of 24, the largest perfect square that I have is 4. So it'll be the square root of 4 times the square root of 6 over 3. And that's how we get 2 root 6 over 3. And then for my second factor, I have x squared is equal to negative 2. Therefore, that solution is x is equal to plus or minus I times the square root of 2. So for my solution set, I have x is equal to plus or minus 2 root 6 over 3 and plus or minus I times the square root of 2. Number 15 is a polynomial that reads x cubed plus 2x squared plus 5x plus 10 equals 0. This polynomial has 4 more terms, so I know that I must use grouping. So just to bring it down, and I'm going to use my colors that you can see the different groups that I have. So just rewriting the polynomial, then I'm going to break it up into 2 groups. I have a blue group and I have a green group. Okay, in my blue group, I have x cubed plus 2x squared. In my green group, I have 5x plus 10. Remember, whenever we have these groupings and we take out our greatest common factor, the inside of the parentheses should look the same on both sides. So when I take out the greatest common factor in the blue group, I take out an x squared, and I am left with x plus 2. So from what I just stated, the parentheses on the green group should also be x plus 2. Now I have to realize what is going to be multiplied by x plus 2 to get 5x plus 10. Well, that is a positive 5. Therefore, I know that one of my factors is x plus 2, and then my other factor is what is being multiplied by each factor, which is x squared plus 5. And I must set everything equal to 0. Now I set my factors equal to 0. Therefore, I have x squared plus 5 equals 0 and x plus 2 equals 0. Solving the x plus 2, that's x equals negative 2. Now let's look at the x squared plus 5. That's x squared equals negative 5. I take the square root of both sides to get x is equal to plus or minus I times the square root of 5. Now let's put that into a solution set. We would have x equals the set of negative 2 plus or minus I times the square root of 5.